Hi, welcome back to Intrusion Detection and Prevention Systems. Today we're going to look at Lab 2, and we're going to continue with an introduction to network packet capturing, except we're going to get a little more advanced. So let's go ahead and see what we're doing today. We're going to look at TCP dump like we have before. Remember, you have to be root to run TCP dump, except on the lab computers, and you can sudo that, etc. Ping, you can ping from any user object. And then to netcat over to port 80 or a web port, you can be any user to do that as well. So netcat allows us to set up raw connections to systems. So in this, the exercises today, we're gonna record information for an ICMP capture, and then we're gonna replay that and look at it. And then we're gonna record information for a web capture, and then we're gonna replay that and look at it. So it's really straightforward. Let's go ahead and get started, and we'll look at it. So first we're gonna do a TCP dump. In this case, we're going to capture on interface ETH0. That's my wired interface. Well, actually, that's the wired interface in the classroom. So we're going to capture on ETH0 if you're using that interface. And we're going to capture just ICMP traffic. And I actually have those commands. If you want to look at them, you can look over here and kind of see what those commands are there inside the lab itself. Okay, so ETH0, and then we're going to write out to ICMP capture.pcap, like that. So we'll just do that. And it doesn't have to be capture. I think over here what we use traffic, I think. Yeah, use traffic on this one. So in this one, I'll just call it traffic. Keep it a little consistent. Traffic.pcap. And then we're going to tell it to capture protocol 1. Protocol 1 is ICMP, Protocol 4 is IP, Protocol 6 is TCP, and Protocol 17 is UDP. Those are ones that are really good to know. Now, if I press enter on this on my computer, which I'll just go ahead and comment that out. If I press enter right there, this will start capturing on ETH0. Now, like I said, ETH0 is the lab computer interface, and that is the wired interface on the computers in the laboratory and possibly your own. But for you, you're going to have to use your interface. If you don't know what interface that is, do an ifconfig, and you can look over and you can see that I'm using WLAN0. ETH0 is not plugged in. So I have WLAN0. I do have a virtual bridge there, but that's for QEMU. But this right here is WLAN0. So I need to change that command up here. Instead of ETH0 for me, I need to put WLAN0. So that's what I'll be capturing on. So very first thing I do is I'm going to go ahead and start that capture. Then I'm going to open up the second window just like we did before. And I'm going to ping something. I'm going to ping, and you can set the number of pings you want to do. So it's say 5 pings, and I'll just do 4.2.2.2. And so there you go. So I've got 5 pings going to 4.2.2.2. And there you go. I have 40% packet loss there, which is not good. But that's all I want to capture. So I'm going to hit Control C over here to stop this. And then I'm going to look at it. So I'm going to TCP dump. In this case, TCP dump. In this case, I'm not going to add any options at all. I'm just going to do that TCP dump. And then I'm going to look at the ICMP traffic just like it is. You can see that right there comes out. Everything is resolved for names. My computer name is Zifu. So right there, it's a ZBook by HP. So I got Zifu right there. We got the b.resolvers, level3.net. We have the ICMP echo request and echo reply. And then over here, we can see we have sequence 4 echo request, sequence 5 echo request, and then the echo replies come way after, which is just, kind of strange for it there. Now, if we want to look at it a little differently, we can put that -NN on there. And that takes out the names right there. So now we're looking at just at IP addresses and numbers. In this case, there are no port numbers because there are no ports in ICMP. ICMP takes place at the network layer of the OSI model. So there are no ports there. If it was at the transport layer, we're using TCP, UDP, etc., then yes, you would have ports associated with it. So here we go. We have no ports. And we can also put an X in there to see what information it's sending, and you can look at kind of the information it sends across. Okay, that's it for ICMP. So we did that. Now we're going to go ahead and capture. Remember, I'm using WLAN 0. You'll use ETH 0 or whatever your interface is called. Could be EN 0, EN 1, could be any number of things. So I'm going to make this now web traffic, which is going to be HTTP traffic for me. I know in the lab I say web traffic, but I'm going to go ahead and put HTTP traffic because specifically I'm going to capture port 80, not 443 or anything else. So in this case, I'm going to say protocol, and you know what? Let's leave off the protocol. I'm just going to do a port. I'm going to say port 80, and I'm going to capture everything that goes across port 80, because anything going across port 80 should be web traffic. So let's go ahead and check this out now. I'm going to do a netcat connection to a remote system on port 80. And so I'm going to go, let's just go to www.yahoo.com on port 80 and press enter. And then we'll do a get HTTP/1.1, enter, and then we'll hit a Control C like that and quit. And that's it. Let's go back over here and we're going to Control C this. It says it captured 13 packets, and let's go ahead and look at that. So we're going to do a TCP dump. We'll do an R on the HTTP traffic, press enter. You see all that stuff comes across there. Let's go ahead and do an INR like that. And we're going to get rid of those names in there. So now it's just IP addresses with ports like that. And I'm going to show you something which is kind of cool here. I'm going to pull out the flags. So I'm just going to pull out these sections using awk. So we're going to do one. This is going to be 1, 2, 3, 4, 5. So I'm just going to do 3, 5, 6, and 7. So let's grab this and say awk, print $3, $5, $6, and $7, just like that. And so that's going to bring out the columns. You can see each column here, which this right here is a column separated by a space. And then we have that as a column separated by a space. Then that's a column separated by a space. And then that's a column. So right here we got column number 1, column number 2, and column number 3 is our source. So let's go ahead and do that. Press enter. Now we can see stuff in a little different light, right? We can see that the source 192.168.0.101, that's me, is going out to 87.248.100.215 on port 80. So you see I left on a high port, 49,000, well, 49,008, and I went to port 80 over on the web server because, I'm going to a web server. Now here's something I wanted to point out to you. The flags. If you remember, TCP does a three-way handshake. UDP does not. TCP does a three-way handshake. So what we have here is SYN. Then you have SYN-ACK. Yes, ACK is not an A. ACK is a period. So SYN-ACK, and then ACK right there. Now after that, we're going push ACK, ACK, push ACK, fin ACK, like that. And then at the bottom we have a reset. Well, if we want to look at that traffic, we can go back over here, put an X in front of that, and we can see like the traffic that's going on through the connection here. Here, let's put the XNN-R to separate everything out, remove the awk, and do this. So this is the traffic that we're sending across right there to the website. If I can find it. Nice. -XNN there. I was like, where is this traffic? And if you look at this and we completely decode the traffic, so we're doing the X on there, then you can see all the information that came back. So, and that all, you can see that's HTML code, and that's what we captured there. So we did capture HTML. Now, if we wanted to open something like Wireshark and look at that, we could open Wireshark and look at that. There's some other utilities that we can use as well and look at the information too. But in this case, what we want to look at is what we just did. And that is, how do we capture that ICMP traffic there And then how do we capture HTTP traffic on a specific port? So in this case, we did a specific port. And in this case, we did a specific protocol. So protocols, if you go to iana.org, iana.org, you can look at the protocol numbers. The ones that are important to remember are 1 is ICMP, 4 is IP, 6 is TCP, and 17 is UDP. Now, of course, a lot of us are going to think right off the bat, well, of course, we have 53, don't you want to know that one, or whatever else, 52, etc. Yes, of course, it'd be nice to know all the protocol numbers, but if you really want to get down to it, you know 1, 4, 6, and 17. And of course, protocol 16, the chaos protocol, you want to know that one, right? But those are our protocols. So I hope this helped. I look forward to, just sending me a screenshot of either just something like this right there would be fine. Oops. Let's see, where is it? Yeah, something like this right here. You send me a screenshot of this right here, or just copy and paste that into your message. That would work just fine. Hope that this helps. I look forward to talking to you next time.